Okay, we've done these instructions, but again, now that we know exactly how the instruction works, let's spend a little time on it. First, let's look at the instruction. This instruction is a 16-bit add. Why? The destination operand tells me so. Okay? Destination operand is a 16-bit register, therefore it is a 16-bit add. When I add AX, which is this portion, to, or CX to AX, I'm going to do this add, so 0075 plus 1001. Let me get 1076. So the high order portion of EAX will remain zeroed out. The low order portion will be 1076. So I look at this. A sign flag of the result is positive, so the sign flag will be cleared. It is non-zero, so the zero flag will be cleared. I did not have a carry out beyond the fixed length, so the carry flag is cleared. Signed overflow, I added positive to positive and got a positive, so that's what I should get. So that's what I'm expecting. Okay? Okay. So let's do, wait, I think I skipped one. Yeah, let's do the same thing with subtraction. This time it's a 32-bit. And it's going to be EAX minus ECX. So in this case, I'm going to take EAX 00000075 minus the value of ECX, which is 00001001. 5 minus 1 is 4, 7 minus 0 is 7, 0, 0 minus 1 I can't do, but I have nothing to borrow from over here. Can't borrow from him, so can't borrow from him or him or him, so what do? Well, what we do here is what actually happens when we wrap around on that binary odometer. What I'm going to do is I'm going to pretend like I've got a secret friend that has an infinite supply of powers of 16. I'm going to take one away from him, loan it to this guy. Okay? 10 is going to take one away and loan it to this guy who is going to take one away, loan it to this guy who's going to take one away, loan it to this guy who's going to take one away, and loan it to this guy so we can finish this. 10 minus 1. 16 minus 1 is 15. F minus 0 is F, 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 F. Okay? So my result in EAX will be F, 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 F074. When I look at the flags, sign flag, my result is negative, so sign flag will be set. It is non-zero. Did I have a carry out? I had positive minus a negative, which is the same as positive plus a positive. So I should expect, when I do positive plus a positive, I should expect a positive. I did not get a positive, so overflow did occur. Now, I kind of skipped over what we're going to do with carry flag, because I'm not carrying out of the last, or from outside, I'm not carrying outside of my fixed length. But here's the deal. What the machine's going to do when it does this instruction is it's not going to do the subtraction. It's actually going to change that to the addition. So it's going to add the negative or the positive to the negative that we were talking about. When it does that, it's going to generate a carry out. How can I tell? Because we had to borrow from our secret friend. So in subtraction, when you have to carry from your or borrow from your secret friend who is beyond your fixed length, that generates a carry flag. Okay? All right, let's talk a little bit about increment and decrement. We talked about them as special purpose versions of add and subtract. And in both these cases, the destination is going to be destination plus or minus, depending on if we're incrementing or decrementing 1. Okay? So the destination operator is treated as an unsigned integer. Be aware of that, okay? And because this is something, it's a special purpose version of add and subtract that's in there because it's used so often, the best choice for destination is to use a register for that, okay? All right, now this, because it's a special version of add and subtract, we would expect, and it does affect the status bits and E flags. However, because it treats the destination as an unsigned integer, it will not change the carry flag. So it affects overflow, sign flag, and zero flag. Okay, one more. Negating. Negating is fairly simple, fairly straightforward. We've done it a lot. In C++, we've used an exclamation in logic. We've used a not sign in set theory. We've used a complement sign. So it is a unary operation. It will, here's what it's actually going to do. Destination equals the 2's complement of the destination. It will negate whatever the destination is, okay? And again, this will affect sign flag, zero flag, and overflow, but not the carry flag. Okay, when we get to class, we're going to do a piece of example code. In this one, we don't have the luxury of writing meaningful, readable comments because we don't really know what X, Y, and Z are, nor do we know why we're manipulating them in this way. However, it is a good practice for how we use the values, what order should I prompt for them, and things like that. So, and here's the basic rule. Before we get to it, prompt for a value only when you need it. Okay? So in this case, I've got, I'm going to be asking for X, Y, and Z. My first part is not going to be an input, a conversion, and moving X and Y and Z to other registers. I'm going to get X, do what I need to it, get Y, do what I need to Y as well as everything else, and so forth. Okay? All right, let's call it, that's a short one, but that's okay. We want to start multiplication in the next video.